We now come to the introduction of Ohm's law in closed circuit. Now, by a closed circuit, we mean a circuit which has battery and which is represented by two unequal lines, as you all know, with a positive end in the higher end, and that is the lower end, that is the negative terminal. And then it is connected by a key here. A key is necessarily to be put in an on position so that the circuit may be working. And then there is a resistance here which has value of capital R ohm. Now this source have a EMF of small e and an internal resistance of small r EMF. Now as we put on this key, the key right at this point of time, as you can see, it is an off mode. Off mode means the current is not able to flow. So that is not a closed circuit. So a closed circuit means when we make this switch in on position. So primarily this has to be made clear that when the switch is put as on position, the current path becomes closed in the sense that it starts flowing in the circuit. So that has to be understood when we mean the term closed circuit. Now what happens to a closed circuit ultimately is the fact that the current, the line current as you call it, is given by I, which is equal to EMF divided by the internal and external resistance of the circuit, which is nothing but capital R plus small r, as the same current is flowing through its two resistances, so they are connected in series. Now if I cross multiply, what I have is E, which is equal to I into capital R plus I into small r. Now what I have to do is I have to find out that what I mean by this IR and what I mean by this IR. Well, as you all understand, that since we are applying Ohm's law where it is stated that V is equal to IR, we need to understand that this IR is a voltage and this IR is also a voltage. But what voltages are they? That should be correctly connected now. So that should be now calculated, that how we are now considering the new potential. So that has to be worked out. In order to work that out, what I do is I will draw the circuit once again for your understanding, and I'm not drawing the key because the point of key is no more applicable now. So I will just draw the circuit now. So we have this current and we have already put it, the whole thing, as you can know that E is I into capital R plus I into small r. Now if you look carefully, we'll find that I into capital R is nothing but the potential drop across this voltage. So we call it V. Now the point remains that what exactly is V? V is what we call the terminal voltage or the potential difference. Now why terminal voltage? Because you see we have a source here and the source can be connected with any one of a resistance which we are using. Say it is a fan rotating, it is a bulb, it is a geyser resistance, it is a top table resistance, whatever it may be. So this is what we call the terminal voltage, that is the voltage that we are having across the resistance that we are using in the external circuit. So this voltage, this VI into R now comes to capital V. So where we want to write it as V is equal to E minus IR. Now that is the equation for Ohm's law in a closed circuit, where we have the external potential drop or the terminal voltage which is connected with the EMF, and since we do not have this much of voltage across the resistance or the external resistance, we call this a lost volt. So this is what is called a lost volt. So what we finally have with us is this equation, which we can write V is equal to E minus I into R. So I'll repeat that this is the terminal voltage, what we are getting across the voltage, and this is the EMF of the circuit or the electromotive force, that is the supply that we are provided, and this is what we call a lost volt, because this voltage is the voltage we cannot apply across the external circuit. So that is all about Ohm's law in a closed circuit. That's all. Thank you, students. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.